The concept of Huygens principle is introduced in section 22.6 of Sir Wave Wheel's College Physics. Here's figure 22.1 from the text, and you see it has an old wavefront coming up to a surface and producing a new wavefront, or an old wavefront coming up to a spherical surface and producing a new wavefront. The new wavefront is drawn tangent to the circular wavelets radiating from the point sources on the original wavefront. And really, I wanted to just kind of like take this this diagram, and I'm not sure if I'm producing exactly the same concept or a different but related concept, but here's basically what's going on. This red line is what it would refer to as the old wavefront, and then this green is the new wavefront. Notice I was able to fix it so that the one of these disappeared over here in this region by drawing a white rectangle before I drew the green circle. But anyway, this is essentially what's going on if I have something going from a, say, water to gas, like this. If this was water and this was air, actually, to make it water and air exactly, I would set n1 equal to 1.333 and n2 equal to 1, and then we would have basically the light would come through, and it would just, instead of appearing to have come from back here at this point, it will instead appear to come from this point. And if this person is watching, they will think, oh, the depth where that object appears is slightly lower. But that is water to air, so if you had a fish down here, you would see the fish a little bit higher in the water. I can also do the other direction. What if n1, if you were viewing something from outside the water, from within the water, then you get kind of an opposite effect. Notice that that's not really there yet, but only when it crosses the interface of the air, only when it crosses the air-water interface. Then what happens is that the actual image appears further away. If you're looking, so this would be water and this would be air. Some other issues that I did notice, these do not stay attached. It's more obvious if I make these a bigger difference. Let's put a 3 in there for that. And you can see that well, they almost are aligned, but you can see they become less aligned as you get further away. Right there you can see they become further and further apart. So this isn't exactly what happens at the surface. There's going to be a little bit of catching up out here. And then there's also the phenomenon of total internal reflection if you're passing from a higher index of refraction to a lower index of refraction. Let's see if this thing will kind of show where that would happen in this case. You can see it's aligned for a little while, but then after a bit, I think by this point you would be getting total internal reflection. Somewhere around there, because it just wouldn't produce the line going in that direction by that point. It occurs to me I ought to go ahead and put reflection into this by making another, say, another red circle going the opposite direction. So this would be with a center of positive p. Yeah, and then it would have the same radius, and it would be drawn before the rectangle so that it'll be hidden. Yeah, that looks, so then we can see both the reflection and the, yeah, I think maybe that rectangle should be quite a bit bigger too. Okay, yeah, watch this. We go boom, and then it reflects back. You can see at some point in there that they that this circle gets away from it and detaches. So I just decided to add in the critical angle here, and so it's drawing a little line from the critical angle back to the object's position and back to the other critical angle. And so you can kind of see that that point where the critical angle is kind of maybe approximately where that green really passes the red. So beyond that point, there wouldn't be any beyond this point here. You would get total internal reflection at that point. Let's see how I incorporated it in case it goes the other direction. 1 and 3, and you can see that it doesn't. It just puts the critical angle at 0, even though it doesn't really exist there. But okay, but now that I've kind of worked out my own, or kind of visual, I want to look at Huygens' principle applied to reflection and refraction in our textbook. It says the laws of reflection and refraction were stated earlier in the chapter without proof, but now we're going to derive these laws using Huygens' principle. Figure 22.22a illustrates the law of reflection. The line A prime represents a wavefront of the incident light. As ray 3 travels from A prime to C, ray 1 reflects from A and produces a spherical wavelet of radius AD. So while this wave is going from here to here, this wave is going from there to there. And recall that the radius of a Huygens wavelet is v delta t. Because the two wavelets having radii of A prime C and AD are in the same medium, they have the same speed v, so AD equals A prime C. Meanwhile, the spherical wavelet centered at B has spread only half as far as the one centered at A, because ray 2 strikes the surface later than ray 1. Because ray 2 strikes the surface later than ray 1. Okay. From Huygens' principle, we find that the reflected wavefront is CD, a line tangent to all the outgoing spherical wavelets. The remainder of our analysis depends on geometry, as summarized in figure 22.22b. Note that the right angles ADC and AA prime C are congruent because they have the same hypotenuse AC, same hypotenuse AC, and because AD equals A prime C. From the figure, we have sine theta 1 is equal to A prime sine, let's see, sine equals opposite over hypotenuse. So sine theta 1 is the opposite of this, A prime D, A prime C. A prime C, what? Oh, that's theta 1 prime. Okay, sine theta 1 is A prime C over AC, and sine theta 1 prime is AD over AC. The two right-hand sides are equal, so theta 1 is equal to sine theta 1 prime equals sine theta 1, and it follows that theta 1 equals theta 1 prime, which is the law of refraction. Alright, Huygens Principle and figure 22.23a on page 788 can be used to derive Snell's Law of refraction. In the time interval delta t, ray 1 moves from A to B. Oh yeah, right here. From A to B. And ray 2 moves from A prime to C. A prime to C. The radius of the outgoing spherical wavelet centered at A, that would be like, the radius of the outgoing spherical wavelet centered at A is equal to the velocity in medium 2 times delta t, and the distance A prime C is equal to the velocity in medium 1 times delta t. Geometric considerations show that angle A prime AC, let's see, A prime AC equals theta 1, and ACB, where's ACB, equals theta 2. From triangles A prime C and ACB, we find that sine theta 1 is equal to the opposite v1t divided by the hypotenuse AC, and sine theta 2 is equal to the opposite v2t over AC. If we divide the first equation by the second, we'll get sine theta 1 divided by sine theta 2, sine theta 1 over sine theta 2 equals v1 delta t over v2 delta t. The delta t's cancel. We get just sine theta 1 over sine theta 2 equals v1 over v2. But we know that v2 is going to be the speed of light, which is the speed medium in v1. Well, I guess v2 is c over n2 and v1 is c over n1. So this is also going to be n2 over n1, and we can derive Snell's law here, which is the law of refraction. The mechanical analog shown in figure 22.23b, they choose to use a barrel. I like to use a marching band concept, where the people over on the right hand side going into the grass first are slowed down, but the people on the concrete keep marching at a regular speed, causing the whole band to turn to the right. Anyway, I just wanted to put those two ideas together, get this kind of visual of the wavefront going to a different surface, and how it actually kind of ends up looking like it is coming from a different point in the wavefront looks like it's coming from a different point in space, and it looks like it came from a different point in time, really, too, since to get them to meet there in the center, I had to do some calculations to figure out the object time and the image time. That way, making it so that the light first struck the wall at t equals 0, and then all of the wavefronts meet up at that point. Anyway, hope you enjoyed.